Hello, welcome to the presentation of our project, Modular Syntax Translator for Assembly Verification. The main functionality of our project is to translate assembly instructions into C code, and the main property of our project is that it is extendable. The main two files that are used by our project is the input file. This input file contains the assembly instructions. We have 14 categories of instructions, and under each category we have a set of assembly instructions. For example, here we have logic register instructions, which consist of a set of instructions, the OR instruction, the XOR instruction, and instruction. And also here we have logic immediate instructions, OR immediate, XOR immediate, and immediate. The second important file is the architecture declaration. Here in this file we defined variables which are useful for the translation process. For example, here we define the general purpose register. This variable could be differ from one architecture to another. Here we use a capital GPR. So any instruction which use the general purpose register will use the GPR variable. And also here we defined the register prefix. This means the how the register prefix should look like. Here we accept R small, R capital, Y letter, and %R. So any of these letters should be acceptable as a register prefix by instructions. Now we want to show how to run our project. We use the command line. We don't have a graphical user interface as requested by the client. We have to specify the name of the input file which contains the assembly instructions, and we have to specify the architecture type. Here we are using the PowerPC, and we have to specify where to store the C code after translation. Now our file has been successfully translated. Let's make a comparison between the input file and the output file. Here we have a comment. This comment in assembly instruction have been translated into C instruction by keeping the comment as it is. And here we have the OR instruction. The OR instruction make ORing between two registers, here R2 and R3, and put the result in R1. This could be translated by using the name of instruction as the name of the function, here OR, and the register indices as an argument parameters here for the function. Now, also here for immediate instructions, one of the parameter of this instruction is the immediate value. So we here OR immediate, we make ORing between the value stored in R2 and value equal 12, which is in binary, and then the result will be stored in R1. Now the same thing, the name of the instruction is the name of the function, and the register indices are used as argument for the function. And now this 12, which is immediate value, we take it is and put this value as an argument for this function. Some of these functions are hard to be translated. For example, the branch value. For example, here we have a branch -20, which means that we have to go to divide this value over 4. The result will be 5, and this minus means that we have to go backward. So we have to go backward five steps and add a new label, and then B should point to this label. Okay, at the end of this file we have two instructions. These instructions have not been translated at the end of this file because they didn't match any defined patterns. We did this to show that our project could be extended by adding a new pattern. This pattern should be defined in the architecture declaration file. Here is the architecture declaration file. We copy the new pattern. Here we use two patterns for these two new instructions. How we define this pattern? We have the pattern which represents how the assembly instruction should look like. Here we start with the instruction name, then followed by a space, then we specify a register prefix. This is a variable which we could be R small, R capital, Y, or %R. Then it followed by a number. This number is the register index. Then followed by space, then comma, then space, then again the register prefix, and then the register index. Now this is the instruction name. It could be move starting with capital letter, could be move with all of its letters capital. And here is the rule. This represents how this instruction should be translated in the C code. Here we use GPR $3. This means that take the variable number 3 here from the pattern and put it here, and also take the variable number 5 from the pattern which reflects the register number and put it here. Now we have to save this file, and then we run the program again. Our file has been successfully translated. Let's see the difference now in the output file. We have to save the new modifications. Now we see that the new added instructions have been successfully translated into C. Thanks for listening.